Oh, sorry. Welcome to this first talk of the seventh edition to the Legacy of Socrates, and I missed my cue. Thank you, Eddie. I'm here with Laura Santamaria, and yeah, she will dive in the topic we didn't talk about at all in all previous editions. So I'm really happy about that. A little word about Laura. She's a developer advocate at Pulumi. You can see that on her shirt, and she's a lot into DevOps. Like she is the co-host of the podcast. She's a co-host of the Austin DevOps meetup, organizer of the DevOpsDays Texas, volunteers at DevOpsDays Austin. It's all DevOps, and she's doing a lot of things about that. So she's well versed in that topic, and that's a good news because we're going to talk about the DevOps aspect, the pipeline, how you push things to production, because you may have a legacy code base, but you certainly have a legacy pipeline. How do you put things into production? If you want to make any change to that code base, you also need to pay attention to how things are delivered to production. And so Laura is going to talk about that. Laura, there you go.
Yay! Well, thank you for having me. I am going to apologize in advance. My allergies decided to act up this morning for my morning, your afternoon probably. So if I start sneezing, I will mute and I will walk away and I will come back and it will all be fine. But thanks for the introduction. And yeah, I kind of embedded in a lot of random places. So, but on that note, I guess need to have a lot of updates to the code base. Maybe there's some dependencies that haven't been updated. It might also be lost knowledge. So the person who built the thing or the team that built the thing is no longer at the company. They're no longer on the project. That lost information, it can mean something is legacy because you still have to figure out how it works. As I start about to sneeze. And then you've also got hidden things. Things that actually lose audio. So I'll wait and we'll vamp a little bit while we're doing.
Yeah, it's okay. I think it's back. It's back, but the audio somehow was lost when.
All right, so I'm gonna go back for just a second.
Just a few seconds, and thank you.
Legacy is unmaintained. It might be outdated. It might be lost knowledge, or could be hidden, meaning it's in that lovely box underneath someone's desk that, as the joke goes, we only find out about when someone unplugs it to vacuum the floor, right? That is some different things that are legacy. Unstable doesn't necessarily mean legacy. A legacy system might be completely stable in its legacy configuration, but perhaps it might be a little bit unstable, which we'll talk about in a bit. But the big thing that I want to get through is that legacy does not mean old. It does not mean that this thing is just forever and a day old. Maybe it's actually still modern. Maybe it's still maintained. Legacy, again, does not mean old. And this is where it gets important, because I'm going to tell you a little story. Back when I joined a tiny little company called Rackspace, I was a junior engineer. And as a junior engineer, I got handed this gigantic legacy pipeline. And it also, but Deconst itself was a documentation delivery pipeline. What that means is it took any kind of updates to the documentation, offered previews on those commits, and then went through and actually delivered that to the user. So the original team had moved on or been laid off, except for one person. This was the person who, as far as I can tell, wrote the majority of the code. His last week was my first week. So suffice to say, there was lots of lost knowledge, and there was lots of stuff I didn't know, and lots of things I didn't have access to. But the key thing to remember here is that none of these technologies are old. If you're not familiar with any of the icons on the slides, I'm just going to walk through them. You've got CoreOS, which is now part of Red Hat, but at the time it was its own entity. Ansible, Docker, Node.js, Python, Ruby, Elasticsearch is there in the left corner. You've got MongoDB, and then a very, very tiny little icon at the very end that I'll explain in just a moment. But to give you a sense of the fact that while this stuff was not old, it was actually, parts of it were kind of old. I'm going to take Elasticsearch. At the time that I picked this stuff up, Elasticsearch 6.2 was the new thing. It was the new one that was out. Dconst was running 1.7. So just a little bit unmaintained there. And I got lucky because they actually had fantastic documentation in general about this pipeline. How was it put together? How did it work? And how did the application that ran around it also work? But this little icon at the bottom is the problem here with this whole situation, because that icon is for a system called Strider CD. Strider CD is a tiny little open source project that runs on Node. So it was running in a fairly modern language. And you can almost think of it as a task runner type system that you might use to replace Jenkins. Now, there was a problem with Strider, is that as any good tiny open source project, it didn't have a lot of documentation. And what I didn't know, again, because this was lost knowledge, none of this was actually really documented, that we modified it a lot to actually be able to use it. So, of course, as with any good legacy system, when it's handed over to someone else, what happens? It breaks. So, of course, it got handed over to me, and within a couple weeks, the pipeline fell over. It wasn't delivering anything, nothing was working, and suddenly I have everyone breathing down my neck, as any good junior engineer would do in this situation, as the only person running the entire pipeline underneath the documentation that serves hundreds of thousands of customers in the home of fanatical support. I panicked. And then I did the one thing that I really hope that everyone takes away from this. I asked for help. I had no access to anything. I had no logs. I had nothing. I just had a little bit of documentation, a little bit of intuition, and the symptoms for how this pipeline was broken. But I knew that there was one engineering manager still at the company. And that one engineering manager, I possibly talked to him a little bit too much. And I just said, Ken, if I give you a beer, like if I buy you a beer, will you please just come help me fix this? And tell me how it broke. So the two of us spent like 2 days trying to figure out how this pipeline broke. We finally figured it out. And Ken, if you're out there, I do still owe you that beer. But then, of course, once you figure out why it's broken, the next thing you have to do is deploy changes. Now, this was a bit of a nail biter for me. Again, junior engineer, first time owning production, having to deploy changes to a pipeline that I don't really understand. So I asked for help again. I owe Ken another beer. He sat with me overnight through this change management process, and we did an overnight deployment, did all kinds of things. But really the story is that I like to believe that as things happened, it got easier. Things started making sense. I started understanding how this pipeline was put together, where things might slightly go wrong. But I might have just gotten used to it breaking. That's also a possibility, right? We kind of get used to that when it comes to legacy code. In my case, I found out about unknown connections to other systems, which I'll talk about in a little bit. that lovely box underneath the desk did actually bite me. So that kind of thing happened. But from this story, I want to share some ideas, some things to know about why this happened and how I figured my way through what this pipeline did. The very first thing I'd say, if you're ever handed a legacy pipeline and you don't know what to do with it, or really any legacy code base, is make a map. Start to understand how everything is put together. This is one of my initial maps. Now you'll see that I had repos. I had these things called preparers, submitters, presenters, content services. This map is actually a much nicer version of the whiteboard that I started out with that had lots of gigantic question marks and, lots of questions like, what is this thing? I have no idea what it is. How does this connect to that? So this is the nicer version. And you can see every little spot on these arrows that says CI/CD. That is where Strider came in somewhere. And I discovered that Strider was the key to this whole thing because it was spinning up Docker containers to run all of these various bits and pieces. It was also running in a Docker container. So you can imagine this was running Docker within Docker, which if you're at all familiar with this, it's not the best idea in the planet. But this map is what saved me and kept me sane as I tried to muddle my way through figuring out this pipeline. The next tip I have for you is check anything that's written down. Now, sure, we've got documentation. And if you have a code base, you have a code base. For legacy code, you at least have something to look at. For me, I had this pipeline that I didn't really have a lot of information about. I got lucky in that the configuration was in code, so I was able to kind of muddle my way through. But I also started looking at commit messages, which is how I actually figured out that Strider had been modified. And believe it or not, you can go back probably and find meeting notes that explain what someone's doing. And in my case, I discovered they actually had a public Slack channel that was archived that I could go back and search to try to figure out how does this pipeline get put together? And what am I missing? What component is there? And in this case, I discovered that box underneath the desk that was running an identity server that was also hidden from me. So I had to go find that using that Slack channel, figure out who still owned it, and ask for access so that I could patch everything that was on there. The other thing, as you would do if you have the option of having some kind of staging environment, is building a sample pipeline. So in my case, Deconst, the open source project, had its own pipeline built with Deconst. So I could go knock that over as much as I wanted and play with it and figure out how it worked. And I used that. So I knocked it over as much as I could so that I could look at the data I was getting from my servers, look at the logs, look at the error messages, look at everything I could find about how this pipeline fell over every single time. And then take that as symptoms for the next time prod fell over. So the next time my pipeline stopped working, typically it was Strider falling over, I could go in, take a look, and realize, oh, hey, it lost access to the identity server again. Or, as I did once, I changed the password on the staging server, not realizing that it changed the passwords in every single other server, including production. Slight problem. I don't know how that pipeline managed to do that, but it did. And that broke everything. So knock it over as much as you can. And once you've done this, as you might guess, you can find your dependencies. Find that server that's underneath someone's desk. Find that repo, that change. Use that information, that map, to discover all of the dependencies that are up there. Now, as you might guess, with any kind of legacy system, including pipelines, people don't just kind of hand it to you and say, here, just make sure it doesn't fall over. We don't really care what you do with it. No. Someone hands it to you and says, hey, can you modernize this thing? Can you resurrect it? Do something fancy with it? I heard about the shiny new tool at a conference. Can we use that instead of using this legacy pipeline that you have? You're going to get that question from your manager. No one hands it to you and says, here, just use this. It's fine. So the thing to remember about a pipeline, even more so I think than a code base, is that it probably has been running for a while. and has been stable for a while, and no one realized it was there because it's just smoothly running in the background, deploying all of your changes, not touching anything. So when you do this kind of work where you might need to change a pipeline, you need to prioritize stability. Your end user should never see a difference. In my case with Deconst, I had two types of end users. I had the end users who were the documentarians, the technical writers, who, as the pipeline ran, they got previews. And they couldn't build anything locally. So unlike perhaps if you're working with a bunch of developers who can go, oh, well, the pipeline's down, I'll build it locally. Oh, it works, let me merge the code. In this case, I had people who couldn't build anything locally. They didn't know what it looked like, and they refused to merge if they didn't have a preview. So I had those users. So obviously stability mattered a ton to them. And then I had the end user actually looking at the documentation. So the people looking at prod. Unfortunately, this pipeline was tied in to the production data, like the production system. So if the pipeline went down, the entire website went down that end users had. Slight problem, just a little bit. So for me, stability was a huge deal. And also, if you happen to be not very good at working under pressure, if you knock over the pipeline that people are used to having stable, people are going to come breathing down your neck. So it's really important to prioritize that stability. For me, what I actually ended up doing was I stood up another pipeline next to the one that I had. So they just saw duplicate previews, but they knew which one was the test version and which one was the real one. So they could continue their work, meaning the tech writers could. And they could just continue doing everything they needed to do. And meanwhile, I had a staging system that I was working on that eventually would become prod. So this is your blue-green deployment. So for me, that worked really well to prioritize stability, validate the changes that I had to the pipeline itself, since obviously I can't validate the changes to the code base in the same way as you can to a pipeline. You have to see it running. So that's really one way to do it. But as you're prioritizing stability, I do want you to ask a question. Is it worth it to spend all that time modernizing something? Maybe because a pipeline just it has been running, maybe all it needs is just to say, hey, Jenkins, let's update you to the latest Jenkins, and maybe update the Java on the box underneath it, and that's good enough. Is there security reasons you have to modernize? In my case, there was, because there was a lot of underlying problems, and Strider kept falling over, and it just wasn't really ready for a production system with all the modifications that it had in a newer platform. So for me, modernization was worth it. But maybe it isn't for you. If it's running on Jenkins, which we'll get to in a little bit, maybe that's okay. And you don't need the shiny new tool. So you need to ask that question of that cost-benefit analysis, that risk analysis, really, of if I modernize this, is everything going to fall over? And how often until we get everything fixed? And could I just get this working without any security issues by just updating what I have? Next, if you're going to think about a pipeline, you need to make sure that everything you add to that pipeline matches everything else. So if you are running, in my case, I was running a preparer. Preparers took the text in Markdown or RST, converted it to HTML in the way that Deconst did things, and posted up a preview. Well, we wanted to add a new preparer. And this, in our case, was actually in RAML and OpenAPI spec, before OpenAPI spec became the merged thing that it is. So I looked at what all the other components had, and I matched that architecture. So whenever you're doing a pipeline and you're adding a new piece to the pipeline, don't be that person that just says, oh, well, I don't like how any of this is built. I'm going to build it my own way. I'm going to change everything. Because the poor person that comes after you is going to hate you. Because here's everything, they started to make sense of it all, then they hit this new thing that's completely different. You might disagree with how that pipeline is built, but if the other 3 pipelines running on this system are all built one way, make your pipeline the same. And then consider if you're going to modernize all of them together or if you'll leave them as is. Again, cost-benefit analysis. And then I do want to talk about thinking about your tools. And this is where normally people think that they get a little angry at me. And that's because most people hate Jenkins. They hate working with it. They hate dealing with it. But the fact is, when it comes to something that is legacy, Jenkins has been around a long time. Someone, I guarantee you, has already shoehorned Jenkins as a pipeline runner into your use case. Don't reinvent the wheel. Consider how much work it's going to take to get this shiny new thing that maybe your boss wants, like Circle CI or something like that, versus standing up the tried and true Jenkins. Or let's say that you're running on mainframes. It was 2019, 2020. Travis announced a partnership with IBM to set up mainframe artifacts from pipelines. Use a tool that makes sense for what the architecture is for your legacy system or your modern system that's running on a legacy pipeline. Don't assume that you have to go to something that's brand new, shiny. You keep hearing about it every conference you go to. That doesn't necessarily mean that it's a good idea for the situation that you have. Now, I want to show you the result of me working on this legacy pipeline. Remember that map? This was the end result of all of those maps. What you see here are various different bits of maps here. The top left should be your left, shows how everything interacts on one of the pipelines, because one of the things I discovered as I was making my map is there were actually two pipelines running side by side, even though everybody told me there was only one. So I had to map them out. So that was one of them. The bottom left is actually showing the various interactions with different repos and how everything was all connected together. And then on the far right, we actually have the big one, and that's all of the interactions. This is after we modernized everything. Modernized, and I'm going to put that in gigantic quotes because we still were using Jenkins. We switched over to Jenkins because it was more stable. We used Jenkins files to actually run everything instead of relying on Ansible as a orchestrator for all of the containers. And we were running on OpenShift because we were using a shared services platform instead of trying to roll our own servers and manage everything there. So for us, this pipeline actually ended up being a lot more stable. We were able to roll this out just before I left the team. And as I mentioned before, someone else is going to come after you, and someone else did. And they really appreciated having tools that they were familiar with to be able to work with, and architecture that didn't change depending on who actually wrote it. Now, I did kind of push through my slides a little bit faster than I normally would like, just because I'm aware of our timing. But I have one last thought for you. In the end, legacy really is just a label. So consider that the next time that you're handed some legacy pipelines. And on that note, I am happy to take questions. I hear there's a chat, which I saw earlier, and there's a little ask questions button down towards the bottom of your screen. Take a look for that if you wanted to ask some questions. And I'm here. Ask away.
Maybe you should not just modernize everything for the sake of it or the thing you're working on. And I think this is an advice that also applies to legacy code in general. This is something we discussed in the past with the Adam Thornhill, for example.
Yep.
He came here and discussed a way to prioritize what to fix, because you could fix many things, and especially if the code base is old and big, but that doesn't mean you should. And if something, for example, is very old, but it's stable and it's working and you don't plan to touch it, for example, it's fine to leave it like that, even if the convention of the code is old, etc. And for the pipeline, is the same. I guess maybe the most difficult part, speaking from my experience, is to anticipate, for example, for the pipeline, if the at some point the infrastructure on which the pipeline is living will change, and that's not under your control, and you have to anticipate that upgrade.
Yeah, we ran into that with Decons, and I mentioned that we moved on to OpenShift onto a shared services platform, and that was why. We were being told, you've been running on your public cloud servers for a while now. We need to reduce cost. And you also need to make it so that other people can get to this. For us also, it was really getting harder and harder to get people access to those servers, just because you had to remember where all the secrets were stored, and handing that from person to person was way too messy. So one thing I would say that is in that cost benefit analysis for a pipeline is using something like Jenkins. And I keep bringing up Jenkins, and I know, like I said, I know people hate Jenkins, but it's on like every system ever, right? Like any shared services platform, someone's going to stand up Jenkins on it, and you don't have to do it. Now that we have like pipelines as code, so Jenkins files, you have orbs with CI, Circle CI, a few others. By moving your pipeline into that and being able to configure it there, you don't really have to change it. So if somebody changes the system underneath you, all you have to say is, my requirement is Jenkins. I don't care how you do it. My requirement is Jenkins. And they're going to go, oh yeah, we're already going to have that for these other 5 projects. That's fine. Off we go. And you can just say, oh, okay, perfect. And you set it up. Yes, there are dependency issues. And this is where, again, you have that cost benefit analysis of how far do I need to update this to keep it running. Now, unlike a code base where the dependencies might matter for security reasons, and like you might really have a huge problem with that, the security requirements of a pipeline are a little bit different in my mind. Yes, you absolutely need to keep them updated. Yes, you absolutely need to think about, can somebody access my pipeline? I mean, we've seen all these supply chain attacks that have been happening. But at the same time, is there some other thing running that might make this easier? If I don't have any dependencies other than my local code, maybe it's okay. But it's really an analysis that you probably are going to have to do with whatever security team you have, as well as just basically say, like, how much of this is worth this, knowing this is how many hours it's going to take, this is how expensive an engineer is to do that work, and then how do you then take that number and reconcile it with the risk of not updating? So if you're actually running only local code and there's no dependencies, which is a miracle, there's no dependencies, there's no nothing, maybe that risk is really low that someone is going to break into your system because you're behind like 5 different firewalls. That's a really, really like simple use case. It's probably not you. So go talk to your security folks. Just saying.
That's very, very true. All right, so we have 2 questions already. The first one is, what did you do to make handover easier for the one after you?
Yes. Oh, that's a great question. First things first, documentation. I can't stress documenting your decisions enough. In my case, I happen to have a gigantic GitHub repo where I could leave an issue for every single decision we made along the way and document why we made that decision. I also typically put that why, or at least the link to the why, as a comment in the configuration as code. Most configuration as code systems actually do have commentary that you can add. So on a line, if I did something weird, I wrote a note like hashtag and then github.com/whatever, link to that issue. And that issue will always be there as long as they're on GitHub, which is probably going to be until the heat death of the universe. So they actually could click that link, go take a look and see, why did I do this weird thing? So that was probably the first one. The second one is really reducing the complexity of logging into systems that might be running the pipeline. So in this case, again, I moved it to a shared services platform. There is a team maintaining access to that, and that was built into our identity servers for the actual company, so that all I had to do was say, okay, you need to add this team. And I would open a service ticket. They would take care of adding that team to everything they needed. And I didn't need to go through and go, okay, you've got access to this server, this server, this server. What am I forgetting? Which is what happened to me. We thought we added me to everything, and I found out when everything broke, not everything was there. So documentation in every way you can, making sure everybody has access. And then again, thinking about, how am I building this? Is this a familiar pattern? Either it's already a pattern that's being used by many other pipelines that people are familiar with, that are part of this whole system, or is it a pattern that is well known in the community? So just like thinking about software architecture patterns, making that familiar, you're doing the same thing with a pipeline. Don't get fancy. I know it's really tempting to do something that you just heard about, you read about on Medium, you thought it was really cool, and you want to just try it. Save that for like a personal project somewhere else. Don't do that on the production legacy pipeline, because someone will hate you. Those probably are my 3 biggest ways of making sure the next person is ready to go.
That's very nice, and that's like everything you say for the pipelines is actually very true for the code too, because like document why you're doing things. We have something called the architecture decision record, which people can have a look at, which is a way to document why.
Yeah.
And don't practice something you just learned on production code at work. Totally, like there are exercises dedicated for that, like playgrounds you can practice, and I encourage people to practice code here. You can probably do the same with pipelines.
Oh, and that reminds me real quick. The diagrams I made are using Mermaid.js, which is you can do it online in a live code editor. You don't have to download the package and build it. Add those diagrams of your pipeline into your documentation, because that kind of, this is how that connects, and this is what this call does. Those were callbacks, like how all of the data is moving through my pipeline. That's really helpful for the next person, because no matter how much you write down and how much code you write out, it's still there for interpretation, whereas that diagram is clear. And that helps, again, when you want to change a component, to know, okay, this is related to that component and that component, and if I change this part of the pipeline, all of these change. And I need to go into each part of these components in this pipeline and update those to match this, which helps a lot also when you're doing that cost-benefit analysis, because you're able to say, oh, well, it's not just changing something here. You notice all these pieces? If I update here, I have to update all these. So no, it's not just this little bit of work, it's all this. So that really matters too.
Nice, thank you. And I'm looking at the time, so we're gonna go quickly on the last question.
Sure.
Which basically the question is there a way to test automatically a pipeline, like the work you're doing, so the test could serve, for example, as a documentation of how the company is? Yeah, go ahead.
Yes. Depending on which system you're using, Jenkins actually does have unit tests and integration tests and smoke tests and all those lovely things. There's a library for that. So if you actually are writing Jenkins files, you can test it. Otherwise, my statement is always stand up a sample. Find some, staging system somewhere that you're allowed to mess with. Try the pipeline there. That's the best place to test it. And do everything you can think of to mess with it. So that's a very, very short answer. I'm going to join the chat. I'm also on Twitter. So you could welcome to ask me any questions you like. I will see if I can answer them. And if not, I'm sure I can find somebody who can help me answer them. So.
Perfect. And as a reminder, all the videos are recorded, will be available on the YouTube channel, and we'll put the links to the slides and all the resources to contact Laura later.
Yeah.
Thank you very much.
My pleasure. Thanks for having me.
Thank you. So let's take a 15-minute break, and then we will have Esther Daniel joining us. We're talking about livable interior design and legacy code. See you there.